Hello. We'll now start with exploring SQL. Let's learn more about what is SQL. SQL stands for Structured Query Language and is used to communicate with a relational database. It's the standard language for a relational database management system. SQL statements are used to perform tasks such as update data in a database, retrieve data from a database. Some common relational database management systems that use SQL include Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, and Oracle. All of them use SQL, structured query language, to pull out data from relational databases. SQL was originally standardized by the American National Standards ANSI in 1986 and by the International Organization for Standards (ISO) in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors include their own proprietary extensions that are not part of the standard, which has resulted in a variety of dialects of SQL. You can use SQL statements such as select, insert, update, delete, create, and drop to accomplish almost everything that you need to do with a database. Although these SQL statements are part of the SQL standards, many data management systems also have their own additional proprietary extensions to handle the specifics of that database management system. These extensions provide functionality not covered by the SQL standard and include areas such as security management and programmability. For example, Microsoft SQL Server and Azure Database Services that are based on the SQL Server database engine use transaction SQL. This implementation includes proprietary extensions for writing stored procedures and triggers, application code that can be stored in the database, and managing user accounts. PostgreSQL and MySQL also have their own versions of these features. Some popular dialects of SQL include Transact SQL, TSQL. This version of SQL is used by Microsoft SQL Server and Azure SQL Services. PGSQL. This is the dialect with extensions implemented in PostgreSQL. PLSQL. This is the dialect used by Oracle. PLSQL stands for Procedural Language SQL. Users who plan to work specifically with a single database system should learn the intricacies of their preferred SQL dialect and platform. So they have similar differences. Like it's as if they all run on the same platform, but each has their own additions, their own type of additions. The SQL code examples in this module are based on the Transact SQL dialect unless otherwise indicated. The syntax for other dialects is generally similar, but may vary in some details. Let's see. SQL statement types. We have three: DDL, DCL, and DML. Data definition language, data control language, and data manipulation language. DDL statements. You use DDL statements to create, modify, and remove tables and other objects in a database. Tables, stored procedures, views, and so on. The most common DDL statements are create, alter, drop, rename. Create a new object in the database. Alter, modify the structure of an object. For instance, altering a table to add a new column. Drop, remove an object from the database. Rename an existing object. The drop statement is very powerful. When you drop a table, all the rows in that table are lost. Unless you have a backup, you won't be able to retrieve this data. The following example creates a new database table. The items between the parentheses specify the details of each column. including the name, the data type, whether the column must always contain a value, not null, and whether the data in the column is used to uniquely identify a row, a primary key. The name, the data type, whether the column must always contain a value, whether the data in the column is used to uniquely identify a row. Each table should have a primary key, although SQL doesn't enforce this rule. Columns marked as not null are referred to as mandatory columns. If you omit the not null clause, you can create rows that don't contain a value in the column. An empty column in a row is said to have a null value. Okay, let's see. We're creating a table here. We create table product. We open parentheses. We have three columns: ID, name, and price. Let's see. Let's see what each column is. This is an integer and it's the primary key. This is the name. It's made of varchar, a maximum of 20 characters, and it's not null. It's not null. It's not. It's mandatory. A price. It's a decimal and null here. What is meant by null here? I think this is the default value. Let me check. It means that it's allowed. It's allowed to have a null value. It's not mandatory. The data types available for columns in a table will vary between database management systems. However, most database management systems support numeric types such as integer, an integer or a whole number, decimal, a decimal number, and string types such as varchar. Varchar stands for variable length character data. For more information, see the documentation for your selected database management system. DCL statements. Previously, we mentioned the DDL statements, which is data definition. Now we need to control the data, which is DCL. Database administrators generally use DCL statements to manage access to objects in a database by granting, denying, or revoking permissions to specific users or groups. The three main DCL statements are grant, deny, and revoke. Grant permission to perform specific actions, deny permission to control specific actions, remove a previously granted permission. For example, the following grant statement permits a user named user1 to read, insert, and modify data in the product table. Here grant, select, insert, update on product, which is the table name, to user1, the name of the user. Now we have the data manipulation language, DML. DML is data manipulation. Now we need to manipulate the data. You use DML statements to manipulate the rows and tables. These statements enable you to retrieve query data, insert new rows, or modify existing rows. You can also delete rows if you don't need them anymore. The four main DML statements are select, insert, update, and delete. Select is read rows from a table. Insert new rows into a table. Update, modify data in existing rows. Delete select existing rows. The basic form of an insert statement will insert one row at a time. By default, the select, update, and delete statements are applied to every row in a table. You usually apply a where clause with these statements to specify criteria. Only rows that match these criteria will be selected, updated, or deleted. SQL doesn't provide "are you sure" prompts, so be careful when using delete or update without a where clause because you can lose or modify a lot of data. There is no undo button here. The following code is an example of an SQL statement that selects all columns indicated by asterisk from the customer table where the city column value is Seattle. Select all from customer where city equals Seattle. What would this return? It would return all the customers that have the city set to Seattle. To retrieve only a specific subset of columns from the table, you list them in the select clause like this. Select, okay, I need the last name, the address, and the city from the customers. So I need only these four columns from the customer table where the city equals to Seattle. If the query returns many rows, they don't necessarily appear in a specific sequence. If you want to sort the data, you can add an order by clause. The data will be sorted by the specified column. As mentioned above, here we'll select first name, last name, address, and city from customer, where city equals to Seattle, but order them by the last name. It's ordered by the last name. We can also then select statements that retrieve data from multiple tables using a join clause. Joins indicate how the rows in one table are connected with rows in the other to determine what data to return. A typical join condition matches a foreign key from one table and its associated primary key in the other table. So basically here we'll be using primary and foreign keys to reference each other. Now, we'll see how it will look like in a second. The following query shows an example that joins customer and order tables. The query makes use of table aliases to abbreviate the table names. Now we can use table aliases for to instead of using all the table name. Which columns to retrieve in the select clause and which column to match in the join clause. Here we'll select which columns we need. But as we see, there is the O dot C dot C dot. What does this mean? This is, we'll see in a second. Here from order as O. This is a table called order. We said represent order as O. So order number will come from the order table. Order date will come from the order table. Now will and customer join customer as C. Here we'll take customer as C. So address from the customer and city from the customer. Now we joined these two tables together, order and customer, on o.customer equals c.id. The customer here in order number dot customer, this contains the foreign key of the customer, which is the ID of the customer, and it's a foreign key. While here in customer, it's the primary key ID. It matches them here and represents all the data and returns it as needed. The next example shows how to modify an existing row using SQL. It changes the value of the address column in the customer table for rows that have the value 1 in the ID column. All other rows are left unchanged. Here we'll see we're updating the customer table. Set address equals to this, where ID equals to 1. Since ID is a primary, it will retrieve only one row, and that row, the address will become 123 High Street. If you omit the where clause, an update statement will modify every row in the table. We need to be very careful because we need to specify very specific conditions for everything to work properly. Otherwise, we'll do something really bad. Use the delete statement to remove rows. You specify the table to delete from and the where clause that identifies the rows to be deleted. Now we'll need to delete from product. We'll delete from the table called product where ID equals 162. ID 162 will retrieve one row which gets deleted. If you omit the where clause, again, a delete statement will remove every row from the table. The insert statement takes a slightly different form. You specify a table and columns in an into clause and the list of values to be stored in these columns. Standard SQL only supports on inserting one row at a time. As shown in the following example, some dialects allow you to specify multiple values clauses to add several rows at a time. Insert into product. In the product, we'll be adding the ID, the name, and the price. Okay, values. These are the values that will be inserted into these columns. This is the ID, this is the name, and this is the price. This was the SQL. This was an exploring SQL. It had a bunch of information, but it's the basic of structured query language. Thanks for watching.